Hi class, welcome to another lesson. This video will be a little bit longer because as per your request, I am doing the whole lesson in a video, not just examples. Anyhow, lesson 4 is about pH, and the key question, or the question which we will be able to answer, we should be able to answer after the lesson is, how is pH used to classify solutions as neutral, acidic, or basic? Before we begin, let's review a few concepts, definitions. Hydrogen ion, remember you have a hydrogen atom, it loses an electron, it gets ionized. So it goes, since electrons have a negative charge, instead of having just the hydrogen, H, you're going to have an H plus. This is the hydrogen ion, remember. Since a hydrogen atom is a proton and an electron, without the electron, this is just the proton. H plus, hydrogen ion is just one proton. Now concentration, that is the amount of solute dissolved in a given amount of solvent, or how much stuff we have dissolved in a solution, such as hydrogen ions per liter. Remember, we defined it on the previous 9 weeks as moles per liter, and I told you could also write it as capital M for molarity, molar concentration. And this basically means the same. So when we have a problem on an exercise and it says 1.0 molar, 1.0 M, it just means that the concentration is 1.0 molar. That's it. Scientific notation, it's a tool scientists use to write numbers, either very large or very small, in a cleaner fashion, faster. For instance, let's say you have 100,000. And we want to write this in scientific notation. Scientific notation, we need a number in between 1 and, let me fix this real quick. In between 1 and 9.99. In this number, it's going to be multiplied times 10, and then this 10 will be raised to some power. So I'm just going to do a blank. For instance, 100,000, if we wrote it in scientific notation, would be 1.0 times 10 to the 5th power. If you don't know how I did this, don't worry, I'm going to explain in a little bit. Aqueous solution, just a solution where water is the solvent. So water is the solvent, pretty simple. And the solvent is the component present in the largest amount. Now we can move on. So what is pH? I bet everyone has heard about pH. You see it like on TV, or maybe you go to a gas station and you're gonna get some water, and you see that, for instance, cold water, it says pH, I think about 9, or you go to the store, to the personal hygiene section, and you see body wash and it says pH balance, just like this one. Or maybe in the past, in whatever science class, you saw the pH scale. But what is really, what's pH? Let me tell you a story when I was in college. I asked the TA, the teacher assistant for one of my chemistry classes, to explain what pH was, and he said, a number used to denote the hydrogen ion concentration of a solution, which is the definition, and that is correct. And I said, okay, thank you, but what's pH? Like, what is it? And he said, well, pH is, we can find it by taking the negative log of the hydrogen ion concentration, which is this equation right here. pH equals negative log of concentration of hydrogen ion. I was like, okay, but what is it? What is the P? What is the H? And I think he got a little upset because he said, all you need to know is the definition and the mathematical representation for the formula. And he was right. But I did some research, and guess what? No one knows what P and what's P and what's H. We know what it does, we know how to define it, but we don't know what the P is or what the H is. And I think that's funny. But I'll share with you something that helped me out through college, and it stuck with me. Hopefully it'll stick with you. So for the P, we write power. And for the H, we write hydrogen. Capital H, so it makes sense, pH. So pH, you can think of it as the power of hydrogen. And it works. This is not scientifically correct, but it works, okay? So don't forget, pH, power of hydrogen. And I think it's funny, this guy, Sorensen, I don't know if I'm pronouncing his name correctly, he never wrote what P and H were, but he came up with the scale. So let's continue. A short backstory. Before we go over exercises and the application for pH, let's pretend we can zoom in into this water drop to the molecular level. We have two water molecules. So I'm going to use Lewis dot structure. That's an ugly O. Let me fix it. So we have one water molecule here. Don't forget about the electron pairs. And then you have this other molecule here. Let me correct this bond because it's not good. It's a little better. So you have these two molecules. They're okay, they're happy, they're just there, moving around. But sometimes this hydrogen on molecule 1 will feel attraction towards the oxygen. So let me do an arrow. And it'll create a bond. It'll leave this molecule 1, and bond with molecule 2. You can think of it as, let's say you went to Costco or Sam's, and you weren't hungry, but then you see this guy offering free samples of like chips or cookies, whatever. And then you see that and you say to yourself, I'm not hungry, but I can have a snack. So I'll be good with a snack, but you're still good without it. So you take the snack because it's free and because it's there. So the hydrogen will bond with the oxygen, not because it needs to bond, but because it can bond, okay? Just like you can take a free sample of chips, this hydrogen will bond with this water molecule, and this will be in the form of a hydrogen ion, remember H+. So molecule 1 will give an H+, a proton, to molecule 2, and this is what you get as a result. Do an arrow. We have our oxygen, 1 hydrogen, 2 hydrogens, 3 hydrogens, and don't forget about the electrons. And I'm going to add a plus sign because remember, this molecule 1, donated a proton, an H plus to this one, so that's why this is positive now. And since molecule 1 lost a positive ion, it's now negative. It went from having 2 hydrogens to having only 1. So we write 1 oxygen, one hydrogen. Let's not forget about the electrons. And this one is negative. So this happens sometimes in water, but it's a very fast process. Now let's say we could focus only on one molecule. It is not technically correct, but it'll help us out for our purposes in high school chemistry. So let's go now only for one water molecule. Oxygen, hydrogen, electrons. So sometimes this water molecule will release a proton, so an H+, or will dissociate into H+ and a hydroxide ion. When this water molecule releases a proton in the form of an H+, this happens. You have H+, O lonely, and OH-. If we wrote it as a chemical reaction, we would have H2O, H+ plus OH-. So water dissociates into hydrogen ion and hydroxide ion. These arrows, they just indicate that this process happens back and forth very quickly. It happens so quickly that it doesn't affect the properties of water, meaning it does not make it acidic or basic. But let's say we could record everything that's happening with the molecules, and then we paused at a very precise instant in time. Even though it will be very small, we would have some hydrogen ions and some hydroxide ions. So we focused on the hydrogen ions and the concentration of them. We will find that the concentration, so I'm going to use brackets, concentration H+ of hydrogen ion in water is a very specific number which chemists do know, 0.0000001 molar. This is the concentration. Very small, but still it's present. It's there. You could find it if you looked at a very specific, precise moment in time. I don't want to write this number all over again, with all these zeros. So we're going to use scientific notation. Concentration of H+ in water equals, now let me show you how to get this in scientific notation. We need to identify the decimal point, which is here. We're going to see how many steps it's going to take us to reach 1, because remember, for scientific notation, we need a number in between 1 and 9.99. So decimal point, 1, 2, 3, 4, 5, 6, 7. So I'm going to write 7 steps. And then it was to the right. Let's go back to blue. We write the decimal point where we stop, so it would be like this: 1.0 times 10. Since we went to the right, we add a negative sign, and the number of steps, which was 7. So the concentration is 1.0 times 10 to the negative 7 molar. This is the concentration of hydrogen ion in water. And before we look at the applications and how to use it, we need to be comfortable with scientific notation, but also we need to know how to use the equation for pH. So pH equals negative log of hydrogen ion concentration. Because now we have the concentration of hydrogen ion in water, and we can find the pH. But we need to understand why we have this log. It's not like someone just invented it and said like, oh, there's gonna be the equation for pH. It has a meaning. And so you're not bored with me, I'm going to call a friend. She's a math teacher. Her name is Ms. De La Pena. I'm going to call her through Zoom, send her an invitation so you can help us and teach us what is log from a mathematical point of view.